In this recording, I'm going to go over how to approach the different ALEKS questions for our isomer workshop. So here's an example of the first question that you're going to see, and we're told to consider this metal complex. I can see I have 1, 2, 3, 4, 5, 6 different ligands, and this is ALEKS's way of drawing the octahedral shape. Remember, this is all 90-degree bond angles, and we have a coordination number of 6. Just to give you an idea of how the ALEKS structure compares to what we draw, coming out of the board, this would be a wedge, this would be a wedge, and then dashes in the back, just so you know how to draw that on your own. So one good thing to do is to start by writing the chemical formula of the complex that is given. Remember, we start with the metal center, and then we're going to list our ligands. I see that I have 2 fluoroligands and 2 hydroxyligands. So I will write that as Cr F2 OH4 square brackets 3 minus. We could name this, and I'm going to name this because this is good practice. This is not necessary for your ALEKS workshop. I know I list in the name, we name the ligands first in an alphabetical order. So we have fluoro and hydroxo, A, B, C, D, E, F. So fluoro goes first, and we've got 2 of them. And fluoro, the ligand, is not on our ligand list because it's not a ligand list in the textbook, but you will see it in ALEKS assignment, so I like to show it here. We know that you name anionic ligands by adding the O, like bromo, chloro, iodo, so fluoro makes sense. Difluoro, and now we have 4 hydroxos. Prefix of 4 is tetra, hydroxo, and then the name of the metal is chromium, right? Cr is chromium. However, this is a anionic complex, meaning the charge of that complex is negative. So we're going to name not the metal, not chromium, but chromate. And there's a list of the metal names for anionic complexes in your study guide. And then we need to include the charge. This is a good time to review the charge. I can see the overall charge of the complex is -3. That means that all of the ligand charges and the charge of the metal must add to -3. I know that each hydroxo is -1, so that's -4 total. Each fluoro is -1, so that's -2 total. So we have total -6. So chromium must be +3 because all of these charges, must add up to that one. We can double check. +3 and -6 does indeed give us -3. So this is chromate 3. So the name difluorotetrahydroxo chromate 3. There are no counter ions in this example, so we would just add the word ion. Review of the name. Okay, back to the workshop. So we have the chemical formula, and we want to decide of these 4 structures given if it's another example of A, so the same as A, just rotated in space, an isomer of A. If it's an isomer of A, it would fall into one of these 4 categories, or an entirely different chemical compound. If it's a different chemical compound, that means it would have a different chemical formula. So let's go ahead and look at this. One thing to keep in mind, talking about isomers, I can see that my two fluoros, they're in the cis position because they're at 90 degrees from each other. So we could add that to the front. Cis dash difluoro tetrahydroxochromate 3 ion. Okay, let's look at the first example. So I can see in the first complex, I have two fluoros, and I can see that bond angle is 180 degrees. That means my fluoros are trans. I have 4 hydroxyligands, just like in complex A, and I have that same, let me erase that, the same chromium metal in the center. It's a chromium in the center, chromium in the center. So I can see I have the same chemical formula as A. However, my fluoroligands are trans from each other. That makes this a isomer of A. Same chemical formula. Right? We'd have our CrF2OH4, 3 minus, but in this case, the fluoros are trans. So these would be cis trans geometric isomers. Where I have cis in this case, trans in that case. Okay, let's go on to the next structure. And I'm going to first just see if all of the atoms are the same. I can see that I do indeed have chromium in the center. I have a fluoro, but I only have 1. And in my complex A, I have 2. And I can see that I have 5 hydroxos. So this is a different chemical formula. Therefore, we have a different compound. Different compound because we have a different chemical formula compared to A. This chemical formula would be, I'll write it up here, CrFOH5, 3 minus. So again, different chemical formula, it's a different compound. Let's look at the next example. I do have chromium in the center. I have 2 fluoros, and I have 4 hydroxos. So I can see this is the same chemical formula. We could write that if we wanted to. CrF2OH4, 3 minus. Same chemical formula, and now we have to see if it's an isomer. So going to this isomer checklist, and I've been talking about this, but I didn't refer to the checklist, I know that I could have cis, so no coordination isomer because there's no counter ion, no linkage isomer because these are not any of the ligands here. Cis trans, I could have cis trans because I'm octahedral with exactly 2 identical ligands. I do not have FASMer. Yes, I'm octahedral, but I do not have 3 identical ligands. I have 4 hydroxos. Again, referring to compound A. And I do not have an optical isomer because, yes, I have octahedral structure, but I don't have 2 or 3 bidentate ligands. So looking at this, I can see that I have the same chemical formula, but my 2 fluoros here are in the cis position also at 90 degrees, just rotated a little bit, so it rotated back, which tells you this is the same as A. Last structure. Got 2 fluoros. No, I've got 3 fluoros. 3 fluoros, 3 hydroxos, 1 chromium, same 3 minus charge. So we have a different chemical formula, which means this is a different compound. Okay, so in your ALEKS assignment, you're going to see the same type of a problem, but potentially different chemical structures. So you want to work through this in the same way. I hope this helps.